Let's start with something simple. Picture yourself outside on a clear night. No phone in your hand, no Netflix humming in the background, just you and the sky. You look up, and for a moment, the world beneath your feet disappears. There they are, stars, tiny specks that look like someone sprinkled salt across an endless black tablecloth. At first glance, they seem like decoration, like a screensaver someone forgot to turn off. But if you sit with them, really sit with them, you realize something a little mind-bending. Every single one of those specks is a messenger from the past. You're not looking at now, you're looking at then. The universe has basically turned your eyeballs into time machines. Congratulations, you've been upgraded without a subscription. Think about it. The light from some of those stars started traveling before humans had Wi-Fi, before humans had wheels, before humans even had, well, humans. When you look at Sirius, the brightest star in the night sky, the light you're seeing took about 8.5 years to arrive. That means the glow hitting your retina tonight set off on its journey back when you maybe hadn't yet finished your last season of procrastination, also known as school. Now, look farther. The light from stars in the Andromeda Galaxy has been en route for over 2 million years. That's before Instagram, before pyramids, before the first "oops, fire is hot" moment by one of our ancestors. 2 million years ago, our distant relatives were figuring out rocks. And here's that same light finally brushing past your eyelashes. Wild, isn't it? Here's the kicker. Stars don't just send postcards from the past. They send entire biographies. Their flicker is packed with information about what they're made of, how hot they burn, and even whether they're wobbling around a hidden planet. Astronomers, bless their patient souls, use that flickering to decode the secrets of the universe. It's like karaoke night, where stars belt out tunes and scientists hold up their cosmic Shazam apps. You don't need a telescope to appreciate it, though. Just the simple act of looking up is a reminder that the universe is always mid-sentence, always telling a story across unimaginable distances. And here's a fun fact that makes stargazing feel even more cinematic. The night sky is both crowded and empty at the same time. Crowded because there are billions of stars just in our galaxy, the Milky Way. Empty because the space between those stars is so staggeringly vast that if our sun were a pea sitting on a football field, the nearest star would be another pea placed several football fields away. So the stars look cozily close, but in reality, they're more like neighbors who never share Wi-Fi passwords and rarely say hi. Now let's talk about the emotional roller coaster of realizing how small we are. You look up, and suddenly your to-do list feels less intimidating. The email you forgot to send? Yeah, compared to a star that's been burning for 10 billion years, it's not that deep. There's something oddly comforting about cosmic scale. It makes human stress shrink. Space is the universe's built-in therapy session. You don't even need to book an appointment. Of course, there's the opposite feeling too, the gulp of insignificance. The "oh no, I'm basically an ant with Wi-Fi" realization. That's real. But don't panic. Think of it this way. Sure, you're small, but you're small and conscious. You're a patch of atoms that somehow became self-aware enough to ask, where does it all end? That's no small trick. Ants don't lie awake wondering if space is infinite. You do. You're the universe trying to peek at its own reflection, and that's something. Let's back up for a second and admire the drama of starlight itself. When a star is born, it spends millions of years fusing hydrogen into helium in its fiery core. Fusion is basically atoms playing high-stakes bumper cars, smashing together so fast they create new stuff, and in the process, they release insane amounts of energy. That energy bursts out as light, which then takes a ridiculously long trip through layers of the star before it even escapes into space. From there, it travels in straight lines at 300 kilometers per second, which sounds fast until you realize it takes that light 8 minutes to reach us from the sun. 8 minutes. So every time you look at the sun, please with sunglasses, not bravely with your corneas, you're seeing it as it was 8 minutes ago. If it disappeared right now, don't freak out, it's not. We wouldn't even know until our lunch break was over. And the more you think about it, the more stars become storytellers in disguise. Their light is like gossip that takes ages to arrive. Imagine your friend sending you a meme, but it takes 2 million years to load. That's basically the universe's Wi-Fi speed. But instead of memes, you're getting cosmic history. That twinkle above you might be the swan song of a star that burned out ages ago, but its light is still traveling, still whispering across space. The star is gone, but its voice remains. If that doesn't feel poetic, nothing will. Okay, let's hit pause on the romance for a second. Let's admit something. Stargazing isn't always glamorous. If you've ever tried it, you know the practical side. You crane your neck, you squint, and suddenly you're playing constellation or random dots. And unless you've got a map, the Big Dipper is the only thing most of us can reliably find. Ancient cultures, though, were pros at this. They didn't just find patterns, they wove entire mythologies. Orion wasn't just a cluster of stars, it was a mighty hunter. Cassiopeia wasn't just zigzag dots, she was a queen, eternally stuck on her celestial throne. The sky was their Netflix, complete with characters, drama, and reruns every night. And here's where science and story shake hands. Those myths weren't wrong in the sense that they were just imagination. They were humanity's first attempts to connect the dots, literally and metaphorically. Today, we use telescopes, satellites, and equations to map the heavens. Back then, they used stories. Both methods ask the same question. What's up there, and what does it mean for us down here? Let's circle back to you, lying there with the sky overhead. That first gaze is more than just sightseeing. It's an initiation. It's the start of a lifelong tug-of-war between awe and curiosity. Because once you notice the stars, really notice them, you can't help but wonder, how far does this go? Is there a wall at the edge of the universe? Does it loop back on itself like some cosmic Pac-Man game? Or is it just endless? And if it's endless, what does that even mean? See, the human brain is built for houses, grocery aisles, and maybe the occasional IKEA maze. We're good with edges, boundaries, walls. Infinity, on the other hand, laughs in our faces. It's like downloading a file that never finishes. You keep waiting, but the loading bar never fills. That's the kind of question space throws at you. Does it stop somewhere, or is it forever? And the first time you really think about that lying under the stars, it hits you in a way no classroom ever could. There's also this sneaky thing space does. It mixes science with philosophy without asking your permission. You start by counting stars, and before you know it, you're pondering mortality, purpose, the meaning of it all. It's as if the night sky doubles as the universe's TED Talk stage. The stars deliver the keynote, and you sit there, humbled, snack in hand, re-evaluating your place in the cosmos. And while all this is going on, while your brain is juggling wonder, science, and existential spirals, remember this: You're participating in one of humanity's oldest rituals. People have been staring up at the night sky for as long as people have been, well, people. Cave paintings, stone monuments, ancient calendars, all proof that our ancestors were as obsessed with the heavens as we are. The same stars they saw are the ones you see now. That connection alone should make you feel less like an isolated ant with Wi-Fi and more like part of a long, curious lineage. Now don't worry, we're not going to solve infinity in this chapter. That would be like promising to fix your entire life in one therapy session. What we are going to do is savor the question, because sometimes the question is the point. The stars don't hand you answers on a silver platter. They hand you a mystery wrapped in distance and light. And that mystery is enough to keep humanity hooked for millennia. So, here's a weird question. What exactly are you looking at when you stare into space? Not the stars this time. We already gave them their standing ovation in Chapter 1. I mean, the backdrop itself, the dark canvas, the negative space that everything else seems to float in. Is it really nothing? Just empty black? Or is there more going on in that dark in-between? Spoiler alert, it's not empty. In fact, empty space is the biggest marketing scam in the universe. If space had a billboard, it would say, "Nothing to see here," while secretly hiding the most important structure of all, the fabric that holds everything together. And yes, I said fabric. Imagine the universe as a giant, invisible bedsheet stretched out across existence. Galaxies, stars, planets, you sipping your coffee, all of it sits on that sheet. The sheet bends, folds, and ripples. That bending, that's gravity. That ripple, that's literally space-time waving hello. This idea came crashing into science thanks to one very famous guy with wild hair, Einstein. In 1915, he dropped his general theory of relativity, which basically said, hey, gravity isn't some invisible force pulling things together, it's the way space itself bends. And everyone else said, wait, what? Space can bend? That's like saying your living room floor can decide to curve downwards and roll your cat into the corner. It sounds ridiculous until you realize, well, that's exactly how the cosmos works. Picture this. You take a trampoline, stretch it tight, and put a bowling ball in the middle. The trampoline dips. Now roll a marble across it. The marble curves toward the bowling ball, not because the ball reached out with magic hands to grab it, but because the surface beneath it is bent. That, in a nutshell, is how space behaves around stars, planets, and galaxies. The universe is basically one giant cosmic trampoline, and we're all the marbles stuck rolling around on it. Except, instead of toddlers jumping on the trampoline, you've got black holes stomping their feet and creating wild sinkholes in the fabric. And just when you think that's cool enough, the plot thickens. This fabric doesn't just bend, it stretches. The whole universe is expanding. Imagine buying a pair of stretchy leggings that keep getting looser every second. Galaxies aren't racing away because they're firing thrusters like space rockets. They're drifting apart because the very stage beneath them is stretching out. Space itself is growing, and we're all just along for the ride. So the next time someone asks, where's the center of the universe? The answer is everywhere and nowhere. It's like trying to find the center of a balloon as it inflates. The whole thing is expanding, not just one part. But hold on. Before we drift too far, let's back up. Because the idea of space as a fabric isn't just poetic, it's practical. The bending of that fabric explains why planets orbit stars, why light curves around massive objects, and why GPS on your phone actually works. Yes, you heard me. Without Einstein's math, your Uber driver might miss you by an entire block. That's because satellites orbiting Earth are sitting in a slightly different patch of curved space than you are. Their clocks tick differently thanks to both gravity and speed. Engineers literally have to adjust for relativity so that when you order pizza, it shows up at your door instead of 3 houses down. So the next time your GPS saves you from being hopelessly lost, you can thank Einstein and the fabric beneath the stars. Now, you might be wondering if space is this bendy, stretchy fabric. Can we tear it? Can it fray? Can it get wrinkled like a badly folded bedsheet? Funny you ask. Turns out, space does ripple. Scientists actually detected it. In 2015, 100 years after Einstein predicted it, the LIGO experiment picked up tiny vibrations, gravitational waves caused by two black holes colliding over 1 billion light-years away. Imagine detecting the faintest tremor in your glass of water. Only the tremor was caused by two cosmic monsters smashing together so far away that their light had barely left when life on Earth was still crawling out of the ocean. That's the sensitivity we're talking about. The universe sends us waves, and our instruments caught them. Space itself was ringing like a drum, and for the first time, humans heard the beat. Okay, let's get a little playful. If space is a fabric, what kind of fabric is it? Cotton? Silk? Polyester? If you had to shop for it, where would you go? The truth is, it's unlike anything in your closet. It's stretchy like spandex, but sturdy like denim. It carries waves like a guitar string, but stretches like taffy. And the weirdest part? It's not made of anything we can touch or sew. It's geometry itself. Space isn't just a place where things sit. It's an active player in the story. Imagine Monopoly, but the board itself changes shape while you're playing. That's our universe. No wonder no one ever really wins. Now, let's bring in time, because time isn't off in its own corner doing Sudoku. Time is stitched into the same fabric. Together, they make space-time. You can't pull them apart any more than you can unbake a cake. And the way this cake stretches affects everything. How fast clocks tick, how fast you age, how far light travels. That's why astronauts orbiting Earth come back ever so slightly younger than their twin siblings down here. The closer you are to strong gravity, the slower your clock ticks. Time itself is flexible, which means that right now, somewhere out there, an alien could technically be watching what you call the future. Mind-bending, right? And if time is woven into this fabric, then movement through space is also movement through time. Every step you take isn't just moving forward in space, it's moving forward in time too. You're always surfing this invisible fabric, whether you realize it or not. It's the ultimate treadmill. You can't stop, and you can't step off. Your whole life is one long ride across space-time. Here's where things get even stranger. On the smallest scales, this fabric doesn't look smooth at all. Zoom in enough, down to the level of quantum physics, and space-time might be frothing, bubbling, fluctuating like the surface of a boiling pot. Scientists call it quantum foam. It's the idea that even space itself, down in the tiniest cracks, is restless, popping with energy and particles flickering in and out of existence. So on cosmic scales, space looks like a smooth, stretchy sheet. But under the microscope, it's a wild sea of activity. It's like zooming into your bedsheet and discovering it's made of tiny ants throwing raves. And just when you think you've got a handle on it, here comes dark energy, the cosmic wild card. Remember how the universe is expanding? Not only is it expanding, it's doing so faster and faster as if some invisible hand is pushing everything apart. That mysterious push? Dark energy. We don't know what it is, we don't know why it exists, but we do know it makes up about 70% of the universe. 70%. That's like realizing your bank account is mostly filled with monopoly money and no one can explain why. Dark energy might be a property of the fabric itself, a kind of built-in fuel that makes space-time stretch. Or maybe it's something else entirely. Right now, it's the universe's best-kept secret. Of course, once you start thinking about space as a fabric, your brain wants to ask follow-ups, like, if it's a fabric, what's it sitting on? Is there some cosmic tailor holding it all in place? Here's the thing. There's no outside. Space isn't sitting in something. Space is the stage and the show. Asking what's outside space is like asking what's north of the North Pole. It's a question that sounds logical until you realize you're trying to outsmart geometry itself. So here you are, lying back, imagining the universe not as a void, but as this living, bending, rippling structure. Galaxies surf on it. Light curves along it. Time itself threads through it. And while it feels abstract, it's not. This fabric literally shapes your life, your technology, your very sense of direction in the world. And if you're feeling the urge to tug on that fabric, to peek underneath and see how it's woven, you're not alone. Physicists are right there with you. They're hunting for the loom behind the weave. Is space-time continuous, like an unbroken sheet, or is it made of discrete pixels, the way your screen is made of tiny dots? Could we ever zoom in far enough to see the threads themselves? That's the thrill and frustration of the cosmos. Just when you think you understand it, it stretches the rules again. But hey, that's what makes this journey worth taking. The stars gave us wonder, but the fabric beneath them? That's where the real magic hides, the invisible stage where the play of the universe unfolds. So, as you roll these thoughts around in your mind, here's the question that lingers. If the fabric of space can bend, ripple, and stretch, what else can it do? Could it fold in on itself? Could it connect two faraway places, like shortcuts in a video game? Could there be tunnels through space-time, waiting for someone brave or foolish enough to step in? That, my friend, is the mystery waiting in the distance. And it's where we're heading next. Imagine this. You get a text message from a friend, but it doesn't arrive right away. It doesn't even take minutes. Instead, it shows up 2 million years late. By the time you read it, the friend has moved, retired, and maybe evolved into a completely new species. That's basically what light is doing every single night above your head. It's the universe's slowest, most dramatic messaging system. And somehow, your eyes are the inbox. Here's the mind-bender. Light doesn't just illuminate, it narrates. Every ray of starlight is a story, a cosmic diary entry that started billions of years ago and has finally wandered into your vision. When you look at the stars, you're not seeing them as they are right now. You're catching up on their old news. It's the ultimate delayed broadcast. And yet, despite being ancient gossip, it still feels alive when it lands in your gaze. But what exactly is this messenger we call light? Strip away the poetry for a second, and light is made of photons, tiny packets of energy that have zero chill. They're born in fiery nuclear reactions inside stars, blasted out at impossible speeds, and then they just go forever. Unless something gets in their way, photons keep racing at about 3,000 kilometers per second. That's fast enough to lap Earth 7.5 times in a single second. Imagine circling the planet before you've even finished saying, "I'm late." Now, If you're picturing photons as hyperlittle delivery drivers, that's not far off. They carry information about where they came from, the star's temperature, composition, even whether it's wobbling thanks to orbiting planets. Astronomers decode this info by spreading the light into a rainbow spectrum, like holding up a cosmic fingerprint. And just like that, photons spill secrets. This star is burning hydrogen. This galaxy is rushing away. This exoplanet might have an atmosphere. Light is the universe's oversharer. And here's a fun twist. Photons don't experience time the way we do. From a photon's perspective, if it could have a perspective, its journey from star to your eyeball happens in an instant. Whether it traveled for 8 minutes from the sun or 8 billion years from a distant galaxy, it never ages. Photons are the eternally fresh produce of the cosmos. Meanwhile, you age just waiting for your microwave popcorn. But light's role in your life isn't just stargazing. Right now, photons are bouncing off your screen and hitting your eyes, letting you read these words. They're bouncing off everything around you, shaping the very act of sight. Without photons, you wouldn't just miss sunsets, you wouldn't see anything. The universe would be invisible, like an unplugged video game. And yet, here's where things get juicy. Light isn't just a pretty glow, it's also a ruler. Astronomers use it to measure distances in space. Ever heard of a light year? It's not a measurement of time, it's distance, how far light travels in 1 year. That's about 9.5 trillion kilometers. Let's pause. 9.5 trillion. If you tried to drive that far in your car at highway speed, you'd be on the road for more than 10 million years. Your playlist would definitely run out. But wait, light also bends. And this is where it becomes more than a messenger. It becomes a trickster. Massive objects like stars, black holes, or whole galaxies can warp the path of light passing near them. This bending is called gravitational lensing. Imagine holding a magnifying glass up to the sky, except the magnifying glass is an entire galaxy cluster. Light from objects behind the cluster gets stretched, distorted, magnified. Sometimes it creates rings, arcs, or even duplicates of distant galaxies. It's like cosmic Photoshop, only the universe is the editor. And we humans, being the curious, nosy creatures we are, take full advantage. Astronomers use gravitational lensing to spot galaxies that would otherwise be too faint to see, even peeking at light from the early universe when stars were just beginning to switch on. So not only is light a messenger, it's also a magician, helping us peer around corners of time. Let's not forget that light also comes in flavors we can't see. Your eyes only catch a tiny sliver of the electromagnetic spectrum, from red to violet. But there's so much more. Radio waves, microwaves, infrared, ultraviolet, X-rays, gamma rays. It's like attending a massive concert, but only hearing one instrument. Telescopes that see in these invisible wavelengths have revealed entire hidden layers of the universe. Cold dust clouds, glowing in infrared, black holes screaming in X-rays, the afterglow of the Big Bang humming in microwaves. Light is like a multilingual messenger, speaking dozens of dialects, and we're just now learning to listen to them all. Now, let's talk about one of light's most underappreciated skills: speed limits. Nothing outruns light. It's the Usain Bolt of physics, permanently holding the record. Einstein built his entire theory of relativity around this. The speed of light is the universe's ultimate speed cap. Want to send a signal faster? Too bad. Physics slams the door in your face. That limit shapes everything: how we understand time, distance, even causality itself. Without it, the universe would be chaos. With it, we get a coherent reality where events actually make sense. But even though photons are cosmic sprinters, their journeys aren't always straightforward. Sometimes they're trapped for ages. Inside the sun, for example, it takes a photon thousands, maybe even millions of years to escape from the dense interior to the surface. Once it finally breaks free, it zooms to Earth in just 8 minutes. So the sunlight warming your skin today began its journey long before human civilizations were scribbling on clay tablets. Next time you step outside, consider that the warmth on your face is ancient cargo finally delivered. And while light mostly brings us warmth and vision, it also brings drama. For instance, when massive stars explode as supernovae, they send out bursts of light so bright they outshine entire galaxies for weeks. Ancient cultures recorded these sudden guest stars in the sky long before telescopes existed. To them, it was divine fireworks. To us, it's the death cry of a star scattering heavy elements into space, the very elements that make up your bones and blood. Without those blinding light shows, you wouldn't exist. In a way, you are starlight that learned how to walk and complain about Mondays. Here's another delicious paradox. Light behaves like both a wave and a particle. It can spread out, interfere, and ripple like waves on water, but it can also act like a stream of individual bullets. Scientists call this wave-particle duality, which is really just a fancy way of admitting light refuses to be pinned down. It's the diva of physics. It changes outfits depending on who's watching. Shine it through two slits, and it creates an interference pattern like water waves. Measure it closely, and suddenly it acts like particles. Light keeps physicists on their toes, forever guessing which side of its personality will show up. And if you think that's strange, get this. Light also defines reality's speed of information. Without it, cause and effect would lose their order. Imagine throwing a baseball and having it hit the bat before you swing. That's what life would be without light's cosmic speed law. It keeps the universe from descending into nonsense. But maybe the most awe-inspiring part is this. Light connects you to the beginning of everything. The faint, cosmic microwave background, the afterglow of the Big Bang, is light that's been traveling for nearly 14 billion years. It's the baby picture of the universe, still floating around us, whispering, "This is where it all started." That glow is everywhere, even in the static on old television sets. Yes, the universe's origin once interrupted your Saturday morning cartoons. So when you lie back and let your eyes trace the sky, remember you're not just looking at sparkles. You're reading letters written in photons, each one carrying history, physics, and poetry across unimaginable spans. You're seeing stars in their youth, their middle age, their final acts, all at once, because light stitches together a patchwork of cosmic time. And then, of course, comes the question that always sneaks in after the awe. If light is such a reliable messenger, can it ever stop? Can its story run out of pages? Or will it keep writing across eternity, revealing new worlds and forgotten ones alike? That, my friend, is where our journey heads next, toward the edges of vision, where horizons disappear the moment you reach for them. Let's play a game. Imagine you're walking toward the horizon. You spot it ahead, a clean line where Earth kisses sky. You walk. The line waits. You walk more. The line keeps moving away like it's teasing you. Try as you might, you never actually arrive. It's the ultimate catfish. Space does the exact same thing. Every time we try to pin down its edges, measure where it stops, define where it folds, box it neatly, it just slides further out. Like a magician yanking the tablecloth but leaving the dishes in place, the universe knows how to pull a disappearing act. And humans, being stubbornly curious, keep chasing after a finish line that was never really there. But let's zoom out, literally. The universe isn't infinite in the way a child's imagination might picture, endless white paper stretching forever. Instead, it's more like a video game with clever level design. You keep walking, but the scenery refreshes, looping, expanding, shifting. You're never given a wall that says, "You've reached the edge, thanks for playing." Instead, you're nudged into a paradox, an edge that exists but always retreats. One of the most famous disappearing edges, the cosmic horizon. Not the pretty pink-orange one you see at sunset, the other horizon, the limit of what we can see in the universe. Light has a speed limit, remember? That means we can only see as far as light has had time to travel since the beginning. Beyond that, it's not that there's nothing, it's just hidden, like rooms in a mansion with the lights off. Our cosmic horizon today stretches about 46 billion light-years in every direction. But tomorrow, it'll be further. The universe is expanding, which means the edge itself is running away faster than we can chase. It's the treadmill from hell, and we're the joggers stuck on it. If this makes your brain itch, good. It should, because the more we measure the universe, the more it behaves like a mirage. The desert analogy fits perfectly. You think you see water shimmering on the sand. You move closer, but the water never arrives. In the same way, the edges of space shimmer, retreat, and shapeshift depending on how we look. And here's the kicker. Edges don't just vanish in outer space. They mess with us in math, physics, even philosophy. Take a circle. Does it have an edge? Sure, you can trace its circumference, but there's no endpoint, no final stop. Keep walking around and you loop forever. The Earth is the same. Sail far enough and you don't fall off. You come back around. Edges often hide in plain sight, masquerading as boundaries but revealing themselves as loops, folds, or moving targets. Speaking of folds, let's talk black holes. These cosmic tricksters are edges in disguise. On paper, they have a clear boundary, the event horizon. Cross it, and nothing, not even light, comes back out. That sounds like a hard edge, right? But here's the sneaky part. From the outside, you never actually see something cross that horizon. To your eyes, objects just slow down, redshift, and fade, never quite vanishing. From the perspective of the unlucky traveler falling in, though, they cross without ceremony. So the event horizon is both an edge and not an edge, depending on who's looking. Talk about a personality crisis. And then there's the ultimate vanishing edge, the expansion of the universe itself. The galaxies we see rushing away, they're not moving through space, they're riding on space as it expands. Imagine raisins in a loaf of bread as it bakes. The dough swells and the raisins drift apart. But unlike your kitchen bread, this loaf never stops rising. At great enough distances, galaxies are receding faster than light, not because they're breaking rules, but because space itself is stretching. Those galaxies cross beyond our cosmic horizon, slipping into regions we'll never see, no matter how good our telescopes get. Edges disappear not because they're fake, but because the universe keeps moving the goalposts. Now, I know what you're thinking. This sounds like chasing a Wi-Fi signal in a dead zone, promising bars just out of reach. And honestly, that's not far off. Cosmologists wrestle with the same frustration. They ask, If the universe is infinite, why can't we see it all? If it's finite, where does it stop? Both questions tie themselves into knots, and the knots are the fun part. Because in science, chasing vanishing edges often leads to bigger discoveries. Consider the famous paradox of Zeno, the philosopher who argued you could never reach a finish line because you'd always have halfway left to go. Step halfway, then halfway again, then halfway again. Infinite steps. You never arrive. Of course, in reality, you do cross the finish line. Try explaining Zeno to marathon runners. But the paradox captures something real about edges. They're slippery. They depend on how you measure, how you frame them, how you chase them. The disappearing horizon is more than a puzzle. It's a lesson in perspective. Humans crave boundaries. We like beginnings, middles, ends. Stories need last chapters. Roads need mile markers. Even video games need the end screens. But the cosmos isn't obligated to give us neat conclusions. Instead, it offers horizons that tease us, recede from us, or dissolve into loops. And here's the beautifully uncomfortable part. Maybe that means endings themselves are illusions. Maybe the end of space is like the horizon, always moving, never final. Maybe the very idea of a stopping point is just a trick of human perception, the way our brains demand closure even when reality refuses. Think about it. Dreams end, but sleep continues. Days end, but time doesn't. Your favorite TV series ends, sometimes badly, but storytelling goes on. Endings are convenient markers, but they're rarely the whole truth. The universe, in all its stubborn vastness, seems to whisper, "Relax, edges are overrated." But don't mistake this for bleakness. There's wonder in the chase. Just because the horizon runs doesn't mean the journey isn't worth it. In fact, it's the chase that makes it meaningful. The fact that we can never hold the edge makes us stretch, measure, wonder, invent. Telescopes, satellites, entire branches of physics. They all exist because we keep trying to grab the ungrabbable. And every time we do, the universe rewards us with something unexpected. Galaxies we didn't know were there, particles we didn't know existed, forces we didn't know shaped us. The vanishing edge is less like a prank and more like a teacher. Every retreat is an invitation. Come closer, think harder, ask again. So next time you see the horizon, whether painted in sunset light or charted in a physics diagram, remember that it's not a wall, it's a moving door. And maybe that's the most honest kind of edge, one that refuses to stay still. Which leaves us with the next tantalizing question. If edges slip, horizons run, and endings dissolve, then what about time itself? Does it end? Or is it just another mirage, another horizon that fades the moment you chase it? That, my friend, is where we're headed next. Take a deep breath. Hold it. Now, let it out. Congratulations. You've just performed a very low-budget impression of the universe. No fireworks, no galactic soundtrack, but the same basic rhythm. Expansion and release. The cosmos has been doing this on a grand scale for billions of years, though with less chest movement and more galaxies. But here's the wild twist. When you exhale, the air eventually settles. The universe, it hasn't stopped expanding since it began. It's like an eternal sigh, one that started nearly 14 billion years ago and hasn't bothered to catch a breath since. And the more we watch, the more we realize this breath is stranger than any human inhale or exhale. So, let's back up to the cosmic beginning, the Big Bang. No, It wasn't an explosion in space, like someone tossed a cosmic firecracker into the void. It was space itself, expanding, stretching, ballooning. Imagine blowing up a balloon with dots drawn on it. The dots, our galaxies, move apart, not because they're zipping through space, but because space itself is doing the stretching. The balloon doesn't need edges for the dots to drift. The stretching fabric carries them away. Now here's where it gets truly weird. You would think after that initial expansion, things might slow down. Gravity should have pulled galaxies back together like a rubber band snapping tight. For a while, scientists assumed exactly that. But the universe, being the overachiever it is, had other plans. Not only is it expanding, it's accelerating. Galaxies aren't just drifting apart. They're speeding away from each other like introverts at a party where someone suggested group karaoke. And the culprit? Dark energy. Sounds like a villain straight out of a superhero movie, right? Beware, dark energy will return in Phase 6 of the Marvel Cinematic Universe. But in reality, dark energy isn't evil. It's just confusing. It's a force we don't fully understand, responsible for about 70% of the universe, pushing everything apart faster and faster. Scientists named it dark, not because it's spooky, but because they have no clue what it actually is. So here we are, floating on a tide we can't control, carried by a breath that never ends. Galaxies, billions of them, glide apart like lanterns set adrift on a cosmic river. Some are already so far away that their light will never reach us again, slipping over a horizon we can't cross. With each passing billion years, more galaxies fade from view, leaving the night sky emptier, the stars dimmer. The universe is stretching itself into solitude. It's poetic in a way. We usually think of breathing as a cycle. Inhale, exhale, repeat. But the universe doesn't inhale. At least, not yet. What if it does? What if one day the expansion slows, reverses, and the cosmos pulls everything back inward? Astronomers call that the Big Crunch, the idea that after an eternity of running, the universe takes one long breath in, collapsing galaxies, stars, even atoms into a final cosmic implosion. End credits roll, lights out. But wait, others argue for a different sequel, The Big Rip. In this version, dark energy doesn't just keep pushing, it keeps accelerating until eventually it tears galaxies apart, then stars, then planets, then atoms, then space-time itself. The universe would end not with a crunch, but with a shredding. The most dramatic exit imaginable. And then there's the crowd favorite possibility, eternal expansion. The universe keeps drifting forever, colder and emptier with each passing epoch, until all that's left is thin radiation and scattered particles too far apart to ever meet again. Not exactly blockbuster material, but haunting in its own way. An endless exhale into silence. Now, before this gets too apocalyptic, let's bring it back to the present. Right now, we're living in the sweet spot. The universe is expanding at a pace that lets us see billions of galaxies, study their light, and piece together this cosmic story. In a few trillion years, future astronomers, if there are any, may look up and see nothing. The sky will be dark, the cosmic neighbors gone, the evidence erased. We are alive at a privileged moment, standing in the middle of the universe's breath, able to watch it unfold. And that changes how we think about existence. Breathing is life's simplest rhythm. It sustains us without thought, a background beat that says, "You're still here." The universe has its own version of that rhythm. Expansion isn't just movement. It's the heartbeat of reality itself. Without it, there would be no galaxies, No stars, no planets, no late-night snacks or Netflix binges. Expansion made everything possible. But here's the mind-bending twist. What lies beyond this breath? If the cosmos expands, what is it expanding into? People imagine it like a balloon filling inside a room. But that misses the point. The universe isn't growing into something, it is the something. Space doesn't need a container. Expansion simply means distances between points increase. It's the stretching of the stage itself, not the movement of actors across it. Still, our brains love containers, edges, walls. Beyond feels necessary, yet maybe beyond is just a word that breaks down at cosmic scale, like trying to use monopoly rules in quantum mechanics. The universe expands, and the beyond expands with it, always out of reach, always part of the same breath. And this is where science turns poetic again. Think of every breath you take. It's temporary, fleeting, but vital. The universe's breath is the same, temporary on cosmic scales, but defining for everything within it. Stars form, planets spin, life arises, all carried on the tide of expansion. Without that breath, the universe would be a static void, frozen, lifeless. Expansion is not just a fact, it's the reason there's a story to tell at all. So next time you breathe in, remember, you're sinking in your tiny way with the grand rhythm of the cosmos. You are part of the same motion that carries galaxies apart, stars into existence, and matter into new forms. Your lungs echo the universe's expansion, not in size, but in spirit. But don't get too comfortable, because the question lingers. If the cosmos is exhaling now, will it ever inhale? Will there be another beginning after this ending? Another rise after the fall? Or is this one long breath all we get? That's where our journey drifts next. Imagine you're out for a walk. You keep moving forward, step after step, convinced that eventually you'll reach the edge of wherever you are. But after a long while, you notice something strange. You're back where you started. No cliff, no wall, no congratulations, you've reached the end of space sign. Just loop. That's the kind of trick geometry likes to play. We usually picture space as a flat, infinite grid, stretching endlessly in every direction, like a sheet of graph paper gone rogue. But what if space is more creative than that? What if it's curved, folded, or looped in ways that our everyday brains struggle to picture? Think of geometry not as cold math, but as choreography. The universe is a stage where space itself moves and bends, shaping how we travel, how we see, even how we exist. Straight lines aren't always straight. Parallel lines don't always behave. And sometimes, endings aren't endings. They're just secret doors back to the beginning. Let's warm up with something you can actually visualize. Picture Earth. From your perspective on the ground, it feels flat. You walk straight ahead, and the road doesn't seem to bend. But keep walking long enough, say around 4,000 kilometers, and surprise, you're back at the starting line. You never saw an edge. The planet's surface is curved, even though your steps felt straight. What looked like an endless line was actually a loop. Now, zoom that idea up to cosmic scale. Space might pull the same trick. Maybe it curves back on itself. So if you traveled far enough in one direction, you'd return from the other side, like a video game character endlessly running through a wraparound screen. Pac-Man didn't invent this idea, but he sure illustrated it well. Einstein had a lot to say about this. His theory of general relativity showed that space isn't just an empty backdrop. It bends and warps, depending on the matter and energy inside it. Heavy objects like stars and black holes act like bowling balls on a trampoline, curving the fabric beneath them. Light follows those curves, matter dances along them, and suddenly the universe is less of a flat stage and more of a flexible, shape-shifting playground. But here's the kicker. We can't step outside the universe to see its full shape. We're like ants crawling across a balloon. The ant thinks it's moving in a straight line, but the balloon's surface curves under its tiny feet. The ant can't see the whole balloon. It only knows the path it walks. We're those ants, except our balloon might have more dimensions than we can wrap our heads around. And shapes get weird fast. Space could be a 3D version of a sphere, looping endlessly, or it could be like a donut, a torus, where paths bend in surprising ways. Yes, you heard me. The universe might secretly be shaped like a cosmic Krispy Kreme. Not as delicious, but mathematically elegant. In such a space, walking straight might loop you not just back to where you started, but along a twisted path that turns endings into beginnings in ways even donuts can't fully capture. This isn't just whimsy. Cosmologists test these ideas by looking at the cosmic microwave background, the faint afterglow of the Big Bang, still visible across the sky. If space loops back on itself, we might spot repeating patterns, like wallpaper where the design tiles over and over. Imagine scanning the sky and finding the same cosmic fingerprint in two directions, proof that the universe curves back around. So far, the evidence leans toward flatness, but on cosmic scales, flat still allows for mind-bending shapes we can't picture directly. And here's where things get dreamlike. A flat universe doesn't necessarily mean infinite. Even a flat sheet of paper can be folded, rolled, or connected in ways that change how you move across it. Geometry lets endings dissolve. You think you've reached the edge of the map, but you're actually circling back, caught in an invisible loop. If you've ever played a video game with a glitchy map, you know the vibe. Walk too far one way, and suddenly the terrain repeats. That's not just lazy coding, it's a tiny metaphor for how geometry can cheat expectations. Space itself could run on similar tricks, though with far better physics than your average bugged-out RPG. And let's not forget time. Relativity ties space and time together. So if space can curve and loop, maybe time can too. Imagine reaching the end of time, only to find yourself at the beginning again, a cosmic reset button hidden in the equations. That sounds like science fiction, but the math doesn't forbid it. Closed time-like curves, as physicists call them, pop up in certain solutions to Einstein's equations. Whether reality allows them is another story, but the possibility alone makes your head spin. Speaking of spinning, black holes give us the wildest examples of curved space. Near them, geometry gets so twisted that straight paths bend back, light itself struggles to escape, and time dilates into a warped mess. It's like nature's way of saying, "Oh, you thought geometry was boring? Watch this." Black holes are extreme reminders that space isn't passive. It shapes reality with invisible curves. But don't worry, the universe isn't all chaos. Geometry also gives us symmetry, rhythm, and structure. Galaxies swirl in spirals, planets trace ellipses, and stars cluster in arcs. These shapes aren't random. They're the visible notes of the universe's hidden song. If space were truly flat and featureless, the cosmos would be dull. Instead, it loops and bends, humming with patterns that turn existence into choreography. So what does it mean for us? If space curves back, if endings melt into beginnings, then our lives, our stories, are part of a bigger loop. The line we think we're walking may not lead to a final stop, but to a return. The universe itself might be less of a straight narrative and more of a song without a last note, repeating themes, circling back, improvising endlessly. And maybe that's the deeper lullaby of geometry. It whispers that the edges we fear, the end of time, the boundary of space, the final chapter, might not exist in the way we imagine. They could be illusions of perspective, like the horizon you can never reach. Every path might curve, every ending might be another doorway, every line another loop. So the next time you step forward, wondering where the road leads, remember, straight lines aren't always what they seem. And the universe, in all its invisible shapes, might be playing a bigger game. One where beginnings and endings are the same move, just seen from different angles. Which raises the next question. If space is a song, endlessly looping, what happens when the melody shifts? What happens when the tune itself changes? That's where we're heading next. Look up at the night sky. All those stars, galaxies, and clusters, like diamonds tossed onto black velvet. Beautiful, right? But here's the real kicker. Most of what you're seeing is nothing. Not the stars, not the glowing galaxies, but the darkness between them. The black canvas holding the lights is the real stage, and it's far stranger than the sparkles that distract us. We like to romanticize light. Poets swoon over starlight. Painters chase the glow of sunrise. Instagram filters practically worship golden hour. But darkness? We treat it like a villain. Something to banish with flashlights, nightlights, or street lamps that ruin astronomers' lives. Yet, in the cosmic sense, darkness isn't absence. It's structure. It's presence. It's the quiet bass line beneath the symphony of stars. So let's step into that dark ocean between galaxies. The vast gulfs where there are no suns, no glowing nebulae, just apparent emptiness. Spoiler, it's not empty, not even close. First surprise, intergalactic space, the in-between zones, makes up most of the volume of the universe. Galaxies? They're just islands, scattered archipelagos, floating in a cosmic sea, but the sea isn't blank. It hums with faint whispers. Lone particles, thin gases, and strange forces pulling strings behind the scenes. Imagine a fog so thin you'd need a cube the size of a skyscraper just to collect a single atom. That's the intergalactic medium. Invisible, delicate, but everywhere. And then there's the cosmic microwave background, CMB for short. That faint afterglow of the Big Bang that still lingers, stretched and cooled over 13.8 billion years. It fills every corner of the universe, even the voids between galaxies. It's like static on an old TV, annoying when you're trying to watch cartoons, but actually the fingerprint of the universe's birth. So when you stare into darkness, you're really bathing in the oldest light there is. But the rabbit hole goes deeper, much deeper, because this darkness isn't just peppered with stray atoms and ancient light, it's weighed down with invisible scaffolding. Dark matter. You've probably heard the name. It sounds like something Darth Vader invented. But dark matter isn't sinister. It's structural. Without it, galaxies wouldn't even hold together. Imagine tossing confetti into the air during a windstorm. That's galaxies without dark matter. They'd scatter apart. Instead, dark matter acts like an invisible web, binding everything with its gravity. Here's the fun part. Dark matter doesn't glow, doesn't reflect, doesn't interact with light at all. So the galaxies you see are like streetlights on a hidden grid of power lines. You're only seeing the glow, not the wiring that holds the system together. That wiring? It stretches right through the darkness between galaxies, forming a cosmic web so vast you'd need billions of light years just to admire a single strand. And then, cue dramatic drum roll, there's dark energy. If dark matter is the scaffolding, dark energy is the expansionist. It's not just filling the gaps between galaxies, it's actively pushing them apart. Think of it as the universe's real estate developer, forever increasing the distance between neighborhoods. That velvet sea you picture as empty, it's swelling, stretching, making galaxies drift further like ships on an ocean that won't stop rising. Now I know what you're thinking. Okay, invisible particles, cosmic background, dark matter, dark energy. But what about actual darkness? The spooky nothingness kind? Fair point. Let's talk about black voids, the underappreciated celebrities of cosmic emptiness. These voids are enormous regions, sometimes hundreds of millions of light years across, where galaxies are scarce. Imagine flying through one. No stars outside your spaceship windows, no galaxies glowing in the distance, just deep cosmic night. You'd think it's boring, but that emptiness is valuable. It's a kind of laboratory. With less clutter from stars and gas, scientists can test how dark energy works, how gravity behaves, even whether the universe is as uniform as we assume. Voids are the universe's negative space, and like in art, the emptiness is as meaningful as the brushstrokes. But even in those voids, there's still something. Particles drift. Neutrinos, tiny ghost-like particles that hardly interact with anything, zip straight through. Photons from ancient stars wander. Magnetic fields thread invisibly. The darkness is alive with subtleties. It's like when you walk into a silent room, only to realize your ears pick up air conditioning hums, floorboard creaks, maybe your own heartbeat. Silence isn't empty. Neither is cosmic darkness. And here's a delicious twist. Our eyes aren't built to see most of what's really there. Visible light is just a tiny slice of the electromagnetic spectrum. What we call darkness is often just light in wavelengths we can't detect. Radio, infrared, X-rays, gamma rays. To us, it looks empty. To a radio telescope, it's a bustling chatter of signals. To an infrared telescope, it's glowing with warmth from distant dust clouds. To an X-ray telescope, it's an arena of violent collisions. Darkness is relative. Our human eyes are just bad at cosmic night vision. So what does all this tell us? That the black void between galaxies isn't absence, it's the backbone of everything. The stage, the scaffolding, the silent carrier of forces we barely understand. The visible galaxies are fireworks. The darkness is the sky they need to explode against. And maybe that flips something inside us. We're used to valuing brightness, clarity, obviousness, but in the universe, it's the unseen, the hidden particles, the invisible webs, the energy with no name that dominates. The stuff we celebrate, the glittering galaxies, are just 5% of the cosmic budget. 95% of reality hides in the dark. That's not depressing. That's thrilling. It means the story isn't finished. It means when you step into darkness, whether cosmic or personal, you're not walking into nothing. You're walking into mystery, into the largest portion of what exists. So maybe next time you look up and see that vast, velvet space between galaxies, don't think of it as empty. Think of it as a whispered promise, a place humming with secrets, or a reminder that reality hides most of itself, and we're just beginning to learn the language to listen. And speaking of listening, what happens if the universe's darkness isn't silent at all? What if it carries rhythms, vibrations, hidden music written into its structure? That's where we're headed next. Imagine turning on an old television set, one of those chunky ones with big knobs instead of sleek remotes. And between channels, you hear that scratchy hiss of static. Annoying? Sure. But here's the mind-bending part. A tiny fraction of that static? Yes. The noise you've been blaming on bad reception wasn't from the TV at all. It was from the universe itself, whispering across time. That static was the afterglow of the Big Bang, still humming away 380,000 years after the universe was born. If cosmic history were a song, this would be the opening chord that's still vibrating in the air. Now, this whisper has a fancy name, the Cosmic Microwave Background, or CMB for short. Don't let the technical label fool you. It's basically the baby photo of the universe, taken long before galaxies, stars, or planets strutted onto the stage. Right after the Big Bang, the cosmos was a fiery soup of particles and light. Think of the world's hottest, most chaotic sauna where no photons could escape. Light kept bumping into matter like a person trying to squeeze through a crowded dance floor at a concert. For hundreds of thousands of years, light was trapped, bouncing endlessly in this dense fog. But then, around 38,000 years in, everything cooled just enough for atoms to form. Finally, light could travel freely. That first light has been coasting through space ever since, stretched and softened by the expansion of the universe until it reached us in the form of a faint microwave glow. That glow is the CMB, the universe's own background music. Here's the thing. You don't need a super high-tech telescope to know it exists. You've literally met it before. Every time you tuned a TV to a dead channel, about 1% of that static was the CMB. Imagine that. Even while flipping through cartoons or late-night shows, you were brushing shoulders with the echo of creation. Pretty humbling for a Tuesday evening snack binge, right? But how does a whisper like this survive for nearly 14 billion years? Think about shouting across a canyon. Your voice bounces, fades, and eventually disappears. The CMB should have fizzled out long ago, but space itself acts like a perfect recording studio, carrying that hum everywhere, forever. No walls to block it, no air to muffle it, just an endless stage. The catch? The universe is expanding. As it stretches, the wavelengths of that ancient light stretch too, sliding down from the fiery glare of visible light into the cooler tones of microwaves. It's like the universe took a scream and turned it into a sigh, but never let it fade completely. Picture it like this. Imagine you're blowing up a balloon with a picture drawn on it. The more you inflate, the more the picture stretches and smooths out. That's what's happened to the light from the early universe, stretched, cooled, and softened into the faint microwave glow we detect today. What began as blazing, blinding radiation has become a uniform background, humming away in every direction you look. It's so even, in fact, that when scientists first found it, they thought something was wrong with their equipment. And here's where the story gets a little funny. Back in the 1960s, two scientists, Arno Penzias and Robert Wilson, were working with a big radio antenna in New Jersey. They kept hearing a persistent noise, a hiss, that wouldn't go away no matter what they did. They thought it might be pigeons nesting in the antenna. And yes, they actually climbed up and cleaned out pigeon droppings to test this theory. But the hiss remained. What they had stumbled on wasn't birds or faulty wires. It was the cosmic microwave background. They had accidentally discovered the echo of the Big Bang, while trying to troubleshoot static. And that, my friend, is how pigeon poop helped earn a Nobel Prize. So why does this faint microwave glow matter? Because it's not just random noise, it's a map. When scientists look closely at the CMB, they see tiny ripples, subtle variations in temperature, about 1 part in 100,000. That might sound boring, but those ripples are the seeds of everything. The galaxies, stars, and planets we see today, all of it started as these slight differences in density, frozen into the CMB. It's like looking at the wrinkles in bread dough and realizing those wrinkles will one day rise into mountains. Without those ancient imprints, the universe would be flat and featureless, with no galaxies and, frankly, no us. So when you look at the CMB, you're looking at the origin story of structure itself. Think of it as the universe's baby blanket, still carrying the folds, creases, and warmth of its earliest moments. Scientists have mapped it with incredible precision, using satellites like COBE, WMAP, and Planck. The result? A glowing, oval picture of the universe when it was just 38,000 years old. That's like pulling out a baby picture of a person who's now 14 billion years old and saying, yep, the smile's still the same. And yet the comparison fits. The CMB really is the first snapshot of everything, taken before cosmic acne, black holes, supernovae, galactic collisions, ever showed up. Let's pause here and imagine this sound, this whisper, as music. If the universe were a concert, the CMB would be the faint hum of the opening chord, still resonating in the background, long after the first note was struck. You can't hear it with your ears, but instruments built for microwaves can. And what they've heard is astonishingly uniform, a near-perfect harmony. But not too perfect. Those little ripples are essential. If it had been flawlessly smooth, there'd be nothing but an endless sea of hydrogen and helium gas. No galaxies, no stars. No you lying here listening to me talk about it. Imperfection, in this case, is the reason everything exists. The universe is basically proof that being a little lumpy can lead to greatness. Here's a wild thought. The CMB isn't just around you, it's inside you too. Because you are made of atoms that formed in stars, which in turn formed because of those ripples in the CMB. Without that faint hiss, there'd be no carbon in your body, no oxygen in your lungs, no earth under your feet. You carry the consequences of that whisper in every heartbeat. You're not just observing the afterglow of creation, you're a direct descendant of it. And there's another mind-bending twist. The CMB also tells us about the ultimate fate of the universe. Because it's stretched and cooled over time, it gives scientists clues about how fast the cosmos is expanding, how much matter and energy fill it, and even the existence of that mysterious stuff called dark energy. In other words, the universe didn't just leave us a baby photo. It left us a cosmic diary, complete with clues about its past and hints about its future. Every faint flicker in the CMB is like a line in that diary, written in a language we're still learning to read. Now I know what you might be thinking. Microwaves, ripples, baby photos. It's fascinating, but also a bit abstract. So let's bring it down to Earth. Imagine you're at a massive party, the kind where music blasts, people laugh, conversations overlap. Hours later, the guests leave, the music stops, and the lights go out. Yet if you walk back into the room, there's still an echo, the faint hum of air vibrating from all that energy. The CMB is that lingering hum, except the party was the birth of the universe, and the echo has been ringing for billions of years. And isn't it curious? This whisper, This background hum is everywhere you look. Point your antenna in any direction and you'll pick it up. It's the one thing that unites every patch of sky. No matter where you turn, no matter how far you drift, the CMB is there. It's cosmic wallpaper, the same pattern wrapping around all of existence. And yet inside that wallpaper, hidden in those tiny fluctuations, is the blueprint for everything we know. So the next time you think about silence in space, remember, space isn't silent at all. It's still singing, still carrying the afterglow of its first breath. We just don't have the ears to hear it. But our instruments do, and through them, we catch that soft refrain, that hum of creation. And here's where it gets even more fascinating. If the CMB is the echo of the beginning, then what about the edges? Does the whisper fade into silence somewhere? Or does it stretch on forever, like a song with no last verse? That's the question waiting for us in the next chapter, where we'll step toward horizons that always seem to slip away, the edges that vanish the moment you try to reach them. If you've ever dropped your phone and watched in horror as it plummeted toward the ground, you already know gravity is rude, relentless, and oddly clingy. It doesn't text you back, but it never lets you go either. You can't bargain with it, can't unsubscribe from it, can't opt out in the settings menu. From the moment the universe drew its first breath, gravity has been the invisible matchmaker, choreographer, and stage director of cosmic life. It's not just a force, it's the storyteller that takes raw matter and sculpts it into planets, stars, and galaxies. Without it, the universe would be a chaotic soup, an eternal snow globe, with the glitter never settling. With it, we get spirals of galaxies, the slow swirl of solar systems, and you sitting there, feeling firmly anchored to your chair. But let's pause. What is gravity, really? Ask Isaac Newton, and he'd say it's a force, like a cosmic string pulling two objects together, no matter how far apart. Ask Albert Einstein, and he'd smirk and say, well, actually, and then go on to explain that it's not a force at all, but the bending of space-time itself. Imagine a trampoline stretched tight, with a bowling ball dropped in the center. The ball makes a dip, and if you roll a marble nearby, the marble will spiral inwards, not because it's being pulled, but because the surface itself curves that way. That's Einstein's gravity, not invisible strings tugging, but a grand reshaping of the stage. Space isn't just the arena where the play happens, it's part of the performance, bending and stretching under the weight of matter. Now here's where it gets wild. Gravity has no off switch. It never clocks out. The sun pulls Earth, Earth pulls you pull Earth right back. That's right, you, with your sandwich and sneakers, are technically tugging on the planet. Don't get cocky though. Earth doesn't budge because it's way bigger, but technically the balance is there. Gravity is like the clingiest relationship ever imagined. It doesn't just hold things, it holds everything. Stars gather into galaxies because of it. Galaxies knit themselves into clusters. Clusters form vast filaments across the universe, a cosmic web sprawling billions of light years. It's less like a single embrace and more like the arms of infinity weaving everything together. And here's something deliciously paradoxical. Gravity is both the weakest force and the most dominant. Electromagnetism, the strong nuclear force, the weak nuclear force, these all make gravity look puny. For example, pick up a paperclip with a fridge magnet and you've beaten the pull of the entire Earth. That's embarrassing for gravity, but over vast distances, gravity never cancels itself out. While other forces fizzle or balance, gravity just keeps stacking. Add more mass, get more pull, and before you know it, you've got stars collapsing, black holes devouring, and galaxies locked in eternal dance. It's like the underdog who seems weak in the beginning but secretly rules the whole plot. Let's bring this closer to home. Without gravity, Earth wouldn't hold an atmosphere. No atmosphere means no air to breathe, no oceans, no rainbows, no Wi-Fi, and that would be the true tragedy. The moon wouldn't circle us, tides wouldn't rise and fall. Forget apple trees dropping Newton's famous fruit, we wouldn't even have apple trees, or Earth, or Newton. We exist because gravity keeps the ingredients together long enough for chemistry, biology, and eventually philosophy to happen. And yet, gravity isn't just a keeper of order. It's also a sculptor of drama. Consider stars. A star forms when clouds of gas collapse under gravity, squeezing tighter until nuclear fusion ignites in the core. That's right, gravity lights the stars. And when those stars run out of fuel, gravity is waiting again, pressing them inward. Small stars fade gracefully into white dwarfs. Bigger ones explode spectacularly into supernovae, leaving behind neutron stars or collapsing further into black holes, regions so warped that even light can't escape. All of this, birth, life, death, is gravity's choreography. It's the universe's way of saying, I gave you the spotlight, and now I'll take it back. Now, let's take a step up to the galactic scale. Have you ever seen pictures of galaxies colliding? Vast spirals of stars tearing through each other like two ghostly pinwheels crashing in the dark. Looks chaotic, right? But here's the twist. Stars almost never crash head-on because there's so much empty space between them. Instead, what you're really watching is gravity, pulling, twisting, stretching those galaxies into new shapes. Over time, the chaos settles into an elegant new form. It's like cosmic pottery. Smash two lumps of clay together, and gravity molds a new masterpiece. Speaking of masterpieces, let's talk about black holes, gravity's most extreme expression. These are places where matter has collapsed so utterly that space-time itself caves in. Think of it as the universe saying, okay, enough, let's fold this part of the map. Black holes are the ultimate gravitational embrace. Once you cross the event horizon, there's no turning back. They don't just pull, they warp time itself, slowing it for anyone who dares approach. To an outside observer, you'd appear frozen at the edge forever. Inside? Well, physics gets blurry there, and maybe reality itself. Einstein's math starts sweating, quantum mechanics raises an eyebrow, and we're left with questions instead of answers. And that, of course, is gravity at its finest, giving us both structure and mystery in the same breath. But here's something to chew on. Gravity doesn't just sculpt the visible, it also plays with the invisible. Galaxies spin so fast that if only visible matter were holding them together, they'd fling apart like a carnival ride without safety bars. But they don't. They stay intact, which means there's extra gravity at work. Gravity from something we can't see. Enter dark matter. It doesn't shine, doesn't glow, doesn't interact with light, but it has mass, and therefore gravity. Think of it as the invisible scaffolding holding galaxies together. Without it, the cosmic web would unravel. With it, we get the grand structure we see today. Gravity, it turns out, is the only reason we even know dark matter exists. It reveals the hidden skeleton of the universe by tugging where nothing visible should tug. And beyond even that lurks dark energy, which sounds like a band name, but is actually something far stranger. Instead of pulling, dark energy pushes, driving the accelerated expansion of the universe. Here's the irony. While gravity forever embraces, dark energy seems to be tearing everything apart. One wants connection, the other wants distance. The cosmos is basically playing out the ultimate love story and breakup at the same time, and we're caught right in the middle. Now I know what you're thinking. This is big, abstract, almost too large to hold in your head. So let's bring it back down. Next time you drop your keys and grumble about gravity, remember that the same force that pulls them to the floor is the one holding galaxies together. It's the same hand-shaping stars, the same curve that bends space-time, the same embrace that's been cradling the universe since the first second. Your annoyance at picking things up is literally connected to the physics of the cosmos. Perspective, right? And here's the kicker. We still don't really understand gravity. We can describe it, predict it, model it. We've built equations, tested them with satellites, mapped them with telescopes. But when we try to marry Einstein's smooth curves of space-time with the jittery world of quantum mechanics, gravity refuses to fit neatly. It shrugs, folds its arms, and says, "Figure me out if you can." Which means, even after centuries of science, gravity remains both intimate and elusive, a constant companion we still don't fully know. And maybe that's the heart of it. Gravity is the reminder that the universe isn't just a place of beginnings and endings, it's a place of connections. Every star you see, every galaxy in the night sky, every atom in your body is part of this endless embrace. The same force that pulls an apple to the ground is the one that binds clusters of galaxies across billions of light years. There is no over here and over there, there is only the weave, the endless reaching of gravity tying it all together. So the next time you look up and see the Milky Way stretching across the sky, think of gravity not as some dull law that makes you drop your phone, but as the ultimate cosmic hug, the quiet architect behind every constellation, every orbit, every corner of the cosmos. And as we drift from this thought, let's carry one last question. If gravity pulls everything together, then what happens when you reach the places where time and space themselves begin to unravel? That's where we're headed next, into the strange frontiers where even gravity's story begins to falter. Picture this. You're standing at the edge of a cliff. Behind you, safety. In front of you, the vast unknown. Now replace the cliff with a place in the universe where even light, the fastest traveler we know, throws up its hands and says, "Nope, I'm not getting out of this one." That's a black hole. Black holes are the ultimate edges, the cosmic do not enter signs. But here's the twist. They're not dead ends. They're more like trapdoors, thresholds where our usual rules of physics start sweating nervously. Instead of endings, they're transformations, cosmic recycling machines that take matter, space, and even time and remix them into something else. So, what is a black hole really? At its core, and oh boy, that's a dangerous phrase here, a black hole is what happens when gravity wins. Take a massive star that's burned through its nuclear fuel. With no more energy to fight the inward pull, it collapses. Imagine a building with all its scaffolding suddenly yanked away. The whole structure caves in. Only in the case of a black hole, the collapse doesn't stop. It keeps going until the star's mass is crammed into a point of infinite density, a singularity. Around that point, space itself caves in, forming what we call the event horizon, the edge of no return. And yet, despite their terrifying resume, black holes are not cosmic vacuum cleaners that go around sucking everything up. That's one of the biggest myths. A black hole, sitting where the sun is now, would hold Earth in the same orbit we enjoy today, albeit a bit darker and colder. Okay, a lot darker and colder. Black holes only gobble you up if you wander too close. Otherwise, they're just there, warping space with quiet menace. But let's lean in a bit closer. What really happens at the edge? Imagine a cosmic escalator where the steps get steeper and steeper until suddenly you're falling so fast there's no way back up. That's the event horizon. For you, the fall might feel quick, seconds, maybe minutes. For someone watching from outside, you'd look like you're slowing down, stretching, fading into redder and redder light until you vanish. You never seem to cross. It's like the universe is playing two different movies. In one, you're gone. In the other, you're frozen forever. Which one is real? Both, depending on where you're watching from. Welcome to relativity's idea of fun. Of course, we can't talk black holes without mentioning the real fireworks. What happens to matter when it spirals in? As gas and dust fall toward a black hole, they don't just drop straight in. They whirl around first, like water circling a drain. Friction in this spinning disk heats things up, really heats them up. We're talking millions of degrees, blasting out X-rays that we can actually detect from Earth. That's right. Black holes announce themselves not by swallowing, but by the cosmic screaming of matter just before it disappears. It's a cosmic warning siren. This way lies oblivion. And yet, here's the part that makes physicists lose sleep. Black holes might not be oblivion at all. They might be recycling plants. Back in the 1970s, Stephen Hawking stunned the world by showing that black holes aren't perfectly black. Thanks to quantum effects at the event horizon, they can leak radiation, tiny bits of energy escaping over time. Slowly, very slowly, this can cause black holes to shrink and eventually evaporate. Picture the most intimidating monster you've ever seen, secretly sweating itself away, one particle at a time. But if black holes evaporate, here's the million-dollar question. What happens to the information that fell inside? Physics has one golden rule. Information can't just vanish. Yet black holes seem to erase it. Toss in a dictionary, and Hawking's radiation doesn't tell you if it was English, French, or Klingon. This is the infamous information paradox, one of the biggest puzzles in modern science. Do black holes really destroy information, or do they hide it in ways we can't yet grasp? Entire conferences, papers, and probably a few shouting matches have been devoted to this. Now, let's scale up. Black holes aren't just the corpses of stars. Some are supermassive beasts millions or even billions of times the mass of our sun. And where do we find them? At the centers of galaxies, including our own Milky Way. Ours is called Sagittarius A, a 4 million solar mass monster lurking 26,000 light-years away. Don't worry, it's not coming for us, but it does act like the anchor of our galaxy, keeping stars whirling in a graceful spiral. Without it, the Milky Way might look less like a galaxy and more like cosmic confetti scattered in the void. And sometimes, these giants put on shows so spectacular they reshape galaxies. When matter falls in, the energy released can blast out jets of particles that stretch for thousands of light years. Imagine turning something the size of your coffee cup into an explosion, brighter than all the stars in the galaxy combined. That's the power black holes wield, not by swallowing, but by what happens just outside their edges. Edges, that's the key word here. We usually think of edges as endings, the cliff, the border, the last page of a book. But in the case of black holes, edges are beginnings of questions. They're mirrors that show us where our understanding falters. What does it mean for something to truly end? If space and time bend into knots we can't untangle, is that an edge of reality itself, or just the edge of our knowledge? And let's not forget, black holes might even be connected to other universes. Some theories suggest they could act like gateways, bridges, or tunnels, what sci-fi fans love to call wormholes. Now don't pack your bags just yet. No one's booking trips through black holes. But mathematically, the idea is there. Edges don't always close things off. Sometimes they open doors we didn't know existed. So next time you think about black holes, don't just imagine cosmic drains swallowing stars. Imagine them as laboratoires at the universe's frontier. They're not just devourers, they're teachers, forcing us to question what we mean by end, by information, by reality. Every horizon is both a boundary and an invitation. And as you drift away from this chapter, picture yourself hovering near that edge. Behind you, the known universe. Ahead, the unknowable. You feel the pull, not as doom, but as a dare. What lies past this horizon? Is it silence or transformation? An ending or a doorway? One thing's for sure. Black holes don't just warp space. They warp our imagination. And in the next chapter, we'll step beyond the edges they guard and ask, what happens when the universe itself has an edge? Or what if it doesn't? Stop me if you've heard this one before. A physicist walks into a bar and orders a drink. The bartender says, "Sorry, we don't serve time travelers here." A man walks into the bar. Again. Time. It's slippery, confusing, and, let's be honest, often the reason we're late for everything. But here's the twist. Time isn't just some cosmic stopwatch ticking in the background while space does the real work. Space and time are dance partners. Inseparable, insequitable, inseparable. One can't move without the other. If space is the floor, time is the rhythm. Together, they choreograph the waltz of the cosmos. And that's not just poetic flair. Ever since Einstein crashed the party in the early 20th century, we've known that space and time are stitched together into a single fabric, space-time. Stretch it, bend it, ripple it. Whatever you do to one, you do to the other. You don't get space or time. You get space-time, a package deal. It's the universe's version of buy one, get one free, except instead of socks, you're getting reality. So let's ask the big question. What is time really? At first glance, time seems straightforward. You wake up, brush your teeth, scroll your phone longer than you should, and the day marches on. Time feels like a conveyor belt, carrying you relentlessly forward. No reverse, no pause button, no rewind, that awkward conversation option. But the deeper you look, the stranger it becomes. Einstein showed us that time doesn't tick the same everywhere. Speed up, and time slows down for you. Get close to something massive, and time drags its feet. This isn't sci-fi. Astronauts aboard the International Space Station literally age a smidge slower than we do on Earth. Not enough to score them a fountain of youth, but enough that the math checks out. In other words, time isn't universal. It's personal. Each of us carries our own timeline, stitched into our experience of space. Imagine going to a movie theater where everyone's watching the same film, but each seat has a slightly different runtime. Some see 2 hours. Others see 2 hours and 3 seconds. That's relativity in action. Same story, different clocks. Now here's the fun part. Time doesn't just measure change, it creates it. Without time, all of space would just sit there, like a paused video game, waiting for someone to press start. Time gives motion meaning. Planets orbit, Stars burn. You grow taller, then older, then grumble about your knees. Time isn't a background track. It's the melody itself. And yet our brains aren't great at handling time. For one, we can't see it. We sense it indirectly, by watching things move, decay, shift. Space we can point to. There's my couch. Time? Try pointing to a minute. You can't. The closest we get is pointing to a clock, which is just a gadget pretending to slice time into manageable pieces. Let's try a metaphor. Space is like a map, and time is the act of traveling across it. You don't have to move, the map exists regardless, but the journey only makes sense because of time. A universe without time would be like a road trip where you're stuck forever in the driveway, car idling, snacks untouched. But here's where things get truly bizarre. Physics doesn't actually forbid time from running backward. The equations that describe the universe, Newton's, Einstein's, quantum mechanics, work just as well in reverse. A scrambled egg could, in theory, unscramble itself. Your spilled coffee could leap back into the cup. The only reason this doesn't happen is entropy. Ah, yes, entropy. The universe's tendency toward messiness. It's the reason smoke spreads out, but never reforms into a neat puff. It's why your room gets messy unless you actively fight it. Entropy is what gives time its arrow, pointing us from past to future. Without it, the universe wouldn't have a story. It would just be a jumbled photo album, all the moments piled on top of each other. And entropy explains why we remember the past, but not the future. You never wake up with memories of tomorrow's lunch. Our brains, like everything else, are stuck surfing the wave of increasing disorder. Time feels like a one-way street because entropy makes sure it never loops back. Still, relativity pokes holes in our everyday sense of time. If time runs differently, depending on speed and gravity, then past, present, and future aren't universal stages. They're relative. For you, something might be happening now that for someone else is still in their future. Think about that. Your present could be another galaxy's not yet. That's not just philosophical, it's physics. Here's a fun brain twist. Some scientists argue that all of time exists at once. Past, present, and future aren't flowing rivers, but fixed landscapes. Imagine a giant library where every book is a different moment. You're not writing the story as you go, you're simply reading it page by page. The flow of time, in this view, is an illusion created by our minds flipping through the chapters. Comforting, terrifying, both. And if time is a landscape, then space is its terrain. Mountains, valleys, plains, all connected, all part of one continuum. When you bend space with gravity, you bend time too. That's why clocks tick slower near black holes. Remember that cosmic bouncer we met earlier? At the event horizon, time itself grinds toward a standstill. From the outside, it looks like anything falling in freezes forever. From the inside, time barrels forward, dragging you past the point of no return. Same event, two experiences. But before you imagine time as some rigid, cruel overseer, let's think of it another way. Time is a companion. It walks with space, not ahead of it or behind it. Every star, every orbit, every heartbeat is part of their duet. Without space, time has nowhere to go. Without time, space has nothing to show. Together they make the universe not just a structure, but a story. Of course, stories come with questions. If time is woven into space, does that mean the universe itself has an age? Yep, about 13.8 billion years. That's how long space-time has been unrolling its plotline. But does that mean there was a before? That's where things get foggy. Asking what happened before time existed might be like asking what's north of the North Pole. The concept itself stops making sense. Still, humans can't help poking at edges. Could time loop back on itself? Could we travel through it? In theory, relativity allows for closed time-like curves, paths that circle back in time. In practice, the universe seems to guard against paradoxes. You know, the classic go back and accidentally prevent your own birth problem. Hawking even proposed a chronology protection conjecture, basically suggesting the cosmos has a strict no-time tourists policy. And yet, wormholes, spinning black holes, exotic matter, all offer tantalizing what-ifs. The math whispers possibilities, even if engineering them is wildly beyond us. Time travel may remain in the realm of science fiction, but the fact that physics doesn't slam the door shut entirely, that's enough to keep the dream alive. Meanwhile, in everyday life, we're already time travelers of a sort. Every second, we move one tick into the future. It's not flashy, but it's unstoppable. The question is less, can we time travel, and more, what do we do with the time we've got? And this is where the poetry sneaks back in. Time isn't just a dimension, it's the measure of experience. It's why we feel nostalgia for the past, anticipation for the future, and presence in the now. Physics may treat all moments as equal, but our human selves know the difference between waiting in line at the DMV and watching a sunset. Time stretches, compresses, dances differently depending on how we feel. So, as you drift from this chapter, imagine space and time as companions walking side by side. Not ruler and subject, not stage and actor. Partners. They've been moving together since the first spark of the universe, weaving everything we know into a seamless performance. But every performance hints at an encore. If space and time are partners, what happens when the music changes? When expansion accelerates, galaxies drift apart, and time itself stretches thinner and thinner. That's where we're headed next, into the vast question of the universe's fate. Will time march forever forward, or will the curtain fall? Here's a riddle for you. What weighs nothing, takes up no space, and yet fills the universe with possibility? Answer: nothing. Well, sort of. Because as it turns out, nothing is one of the most misleading concepts humans have ever invented. We like to imagine the void as a blank page, a clean slate, an absolute emptiness, so empty it would make a vacuum cleaner jealous. But physics shakes its head and laughs at our imagination. In science, nothing isn't actually nothing. It's buzzing, wriggling, restless, not a void, but a stage alive with activity. So, buckle up. We're about to step into the universe's trickiest magic act, how nothing manages to be something. Let's start simple. Imagine you clean your entire room. Every sock folded, every crumb vacuumed, every mystery mug finally returned to the kitchen. You collapse onto your bed, victorious, and declare, finally nothing. But if we zoom in, say, really zoom in, there's still air molecules bouncing around. Light from your lamp is bouncing off the walls. Gravity is tugging at everything. Your room is never actually nothing. It's just less messy. Now take that idea to space. If you look up at the night sky, the gaps between stars seem like bottomless holes of emptiness. Cold, black nothingness. Except not. Even in the deepest intergalactic void, space isn't truly empty. It's seething with invisible ingredients. Here's where things get deliciously weird. According to quantum physics, the vacuum, what we might call nothing, isn't just sitting around twiddling its thumbs. It's alive with what scientists call virtual particles. Picture the darkest field you can imagine. Now, imagine fireflies blinking in and out, not staying, not settling, just appearing and vanishing. That's what the quantum vacuum does. Little particle-antiparticle pairs pop into existence, hang out for a microscopic fraction of a second, and then annihilate each other. Poof, gone. And you don't get to catch one, no matter how quick your butterfly net. They're too fast, too fleeting. But their brief lives matter. They leave fingerprints on reality, tiny fluctuations that ripple outward, shaping the universe itself. Think about that. Even in the emptiest place possible, nature refuses to be silent. So why do these flickers happen? Because in quantum mechanics, rest doesn't exist the way we think it does. Even when you cool something down to absolute zero, the coldest temperature imaginable, particles never fully stop moving. There's always a hum, a jitter, a leftover buzz called zero-point energy. It's like the universe has insomnia. No matter how hard it tries, it can't completely shut off. Even its idea of sleep comes with tossing and turning. And this jitter is the heartbeat of nothingness. It keeps those virtual particles popping in and out, keeps space itself from collapsing into silence. The void has a pulse. Don't take my word for it. This isn't just abstract math. Back in 1948, Dutch physicist Hendrik Casimir predicted a bizarre experiment. Put two uncharged metal plates very close together, just a few nanometers apart, and they'll actually pull toward each other. Why? Because between them, fewer virtual particles can flicker into existence. Outside the plates, the buzzing is stronger. That imbalance creates a push, squeezing the plates together. So even when you try to create nothing in the lab, nature sneaks in through the back door. The vacuum itself becomes a player in the game. Now here's the real kicker. The entire universe may have sprung from nothing. Cosmologists suspect that quantum fluctuations, the same flickers of virtual particles we've been talking about, might have played a role in the Big Bang. Imagine a microscopic bubble of energy, popping up out of the vacuum, inflating into everything we now see: galaxies, planets, cats demanding dinner at 3 a.m. It sounds wild, but it's consistent with the rules of physics. Nothing doesn't stay nothing. Left alone, it seeds possibility. It's a cosmic loophole from emptiness, birth. Of course, all this raises awkward questions. If the void is never truly empty, then does nothing even exist? Or is it just a word we invented to describe a place where there's less stuff than usual? Philosophers have wrestled with this for centuries. Aristotle thought nature abhorred a vacuum. Medieval thinkers argued about whether God could create nothingness. And now physicists come along with equations saying, actually, your nothing is full of particles doing the cha-cha. So maybe the problem isn't the void. Maybe the problem is us, our stubborn insistence on imagining nothing as a kind of cosmic blank page. The truth is stranger. The void is more like a restless canvas, paint splattering on and off before any artist even shows up. And if you thought virtual particles were unsettling, meet dark energy, the heavyweight champion of cosmic nothingness. We discovered in the late 1990s that the universe's expansion is accelerating. Galaxies aren't just drifting apart, they're racing away faster and faster. Something must be pushing them. That something? Dark energy. Here's the kicker. The best guess is that dark energy is just the energy of the vacuum itself. Nothingness with ambition. The void. flexing its muscles and reshaping the cosmos on the largest scale. So when we talk about nothing, we're not talking about absence. We're talking about the very thing that steers the destiny of the universe. Nothing is bossy. Nothing has power. Nothing is everything. Now, before you think this is all lofty cosmology, remember, we deal with nothing all the time. Ever had that awkward silence in a conversation where nobody knows what to say? That social nothingness, a gap so heavy it feels like it has its own gravity. Or think of the pause before the punchline of a joke. That moment of suspense, that's a tiny void, pregnant with possibility, where laughter is about to burst forth. Even music relies on nothing. Without pauses between notes, Beethoven would sound like a blender chewing on marbles. Silence gives shape to sound, just as nothing gives shape to existence. We fear nothingness. We equate it with endings, with absence, with the final page closing. But physics whispers something different. Nothing is not the end. It's the wellspring. It's the hidden stagehands pulling the ropes behind the cosmic theater curtain. When you stare into what looks like emptiness, you're actually looking into a restless workshop of creation. A place where particles wink in and out, where energy hums, where the seeds of galaxies might be planted. The void is alive. So next time you hear the phrase "out of nothing," don't scoff. In the quantum universe, that's how everything happens. Nothing is never truly nothing. It's possibility in disguise, a magician's hat stuffed with rabbits we can't yet see. But if nothing is so busy, so alive, what does that mean for the far future of the universe? If the void itself has power, if empty space is pushing galaxies apart, then where is it all heading? That's where we'll turn next, into the destiny of everything. When the stars fade, the galaxies drift away, and the universe confronts its final act. Is the end really an end, or just another beginning, hidden in the illusion of nothingness? Picture this. You're blowing soap bubbles on a sunny afternoon. One floats up, shimmering with all the rainbow colors of a candy aisle. Then another drifts beside it, then a third. Before you know it, you've got a little bubble cluster, each one wobbly, fragile, and perfectly round. Now imagine those bubbles aren't just bits of soap film, but entire universes, each one containing galaxies, stars, black holes, possibly alien civilizations arguing about pineapple on pizza. That's the wild idea behind the multiverse. Maybe our universe isn't alone. Maybe it's just one bubble in a cosmic foam party. Sounds like science fiction, right? But hang on. We're going to dive into the science-y side of this strange thought. Because physicists, in their free time, which apparently involves rewriting the rules of reality, have been seriously asking, could there be more than one universe? The multiverse is basically the universe's way of trolling us. Just when we think we've mapped out the rules, Big Bang, expansion, galaxies doing their thing, science whispers. But what if there's more? What if is the engine of all of this? What if our cosmos isn't the only show in town? What if other versions of reality exist, each with its own script? Maybe there's a universe where you're a professional opera singer, another where dinosaurs never went extinct, and T-Rexes have TikTok accounts. And maybe, somewhere out there, there's one where you actually finished that New Year's resolution. Okay, fun to imagine. But where's the science? Let's rewind to the Big Bang. Scientists think that right after our universe burst into existence, it went through a turbocharged growth spurt called cosmic inflation. In less than a blink, space ballooned faster than the speed of light. Now here's the twist. Some theories suggest inflation didn't just happen once. it might still be happening, in different places, bubbling off new universes all the time, like popcorn in a microwave. One kernel pops, then another, then a whole bag of universes bursting into existence. That's called eternal inflation. Our universe would just be one popped kernel among countless others, which means the multiverse could be less like a neat bubble bath and more like a never-ending cosmic popcorn party. Here's where it gets spicy. If these universes exist, they might not follow the same rules as ours. In one bubble, gravity might be stronger. In another, atoms might not even form. Some could be utterly lifeless, others bursting with stars, and a few maybe even hosting life forms asking the exact same questions we're asking right now. Think of it like a cosmic recipe book. Our universe turned out with just the right balance of ingredients: gravity, electromagnetism, chemistry, for stars and planets to bake nicely. But flip the page, and the recipe might call for way too much salt or no sugar at all. Those universes would flop. And yet, somewhere in the multiverse cookbook, there could be infinite variations, which makes you wonder, are we just one lucky dish that happened to come out edible? Now here's a dramatic thought. What happens if two universe bubbles touch? Picture two soap bubbles drifting together. They bump, merge, and sometimes pop. If that happened on a cosmic scale, the collision might leave scars. Some scientists have even looked for circular patterns in the background radiation of our sky, like bruises that could hint at past bubble-bumping events. So far, the evidence isn't solid. But the possibility? Oh, it's delicious. Imagine our universe carrying a faint birthmark from a cosmic fender bender with another reality. That would make the night sky less like a quiet ceiling and more like a battlefield of universes brushing past one another. Of course, the multiverse doesn't stop with bubbles and popcorn. Enter quantum mechanics, which loves to complicate things. You've probably heard of Schrödinger's cat, the famous thought experiment where a cat is both alive and dead until someone checks. The many worlds interpretation says, when a quantum choice happens, reality splits. One universe where the cat lives, another where it doesn't. Now scale that up. Every time you make a decision, coffee or tea, Netflix or sleep, the universe could split into two versions. Infinite yous, branching out like a tree. Somewhere, another you is reading this, but paused to make popcorn. Somewhere else, another you gave up after the first paragraph. It's both dizzying and strangely comforting. Reality might be branching like a choose-your-own-adventure book, except every ending happens somewhere. You've probably noticed the multiverse sneaking into movies and comics. Superheroes jump between timelines. Cartoon characters meet their alternate selves, and Spider-Man hangs out with multiple spider people. Why do we love it so much? Maybe because it tickles the ultimate what if. What if things had gone differently? What if another version of you made a different choice and wound up living a different story? It's part wish fulfillment, part existential crisis, all wrapped in a neat sci-fi bow. And while Hollywood plays it for drama, scientists are wrestling with whether something like this could actually exist. Okay, time for some honesty. We don't have direct proof of the multiverse. None. Zilch. Physics gives us reasons to suspect it might be real, like inflation, quantum quirks, or mathematical elegance. But testing it? That's the hard part. You can't just pop over to the next universe with a spaceship. If other universes exist, they may be forever beyond our reach. That doesn't mean the idea is useless. Even without proof, the multiverse helps scientists think about big questions like, Why does our universe have the laws it does? Why does it seem so perfectly tuned for life? Are we special, or just one of countless cosmic lottery tickets? It's humbling. And maybe that's the point. Let's circle back to that first image. Bubbles floating in sunlight. Each one catches a shimmer of color, each one perfectly round, each one temporary. Now think of the multiverse the same way. Maybe our universe is just one bubble, fragile yet luminous, drifting alongside countless others in an unseen sea. We'll never see them directly, but the possibility stretches our imagination, reminding us that reality might be far stranger than the version we wake up to every morning. And here's the kicker. Even if there are infinite universes, we only ever get to live in this one, which makes it precious. This bubble, our bubble, carries our skies, our stories, our music, our laughter. Even in the wildest multiverse theory, this universe is our home. So where does that leave us? With a tantalizing question. If there really are other universes, is there a horizon where ours ends and another begins? Can space itself have an edge, or does it just keep spilling into other bubbles forever? That's the cliffhanger. Because the more we chase this idea, the more it nudges us toward an even bigger mystery. Not just whether other universes exist, but whether space itself has a boundary. Is there a final edge to reality, or does it go on endlessly into horizons we'll never touch? That's where we'll head next. Here's a weird question to kick off your night. What happens when the universe gets old? I don't mean needs reading glasses and starts complaining about kids these days. Old. I mean really old. So old that stars stop being born, galaxies unravel, and time itself feels like it's scrolling endlessly with no new episodes to watch. That's where we're heading tonight, a road trip into the deep, deep future, way past anything our species, or probably any species, will ever see firsthand. Buckle up, because this is less, where do you see yourself in 5 years? And more, what does the cosmos look like in 100 trillion years? Let's start with the near future of the universe, which is already a bit depressing if you like fireworks. Stars are basically cosmic campfires. They burn through their fuel, shine for a while, then sputter out. Right now, we live in the golden age of starlight. The universe is absolutely packed with stars, and new ones are still being born in nurseries of dust and gas. But this won't last forever. One day, the star factories will shut down. Clouds of raw material will get used up or scattered, and the assembly line will stop rolling. Picture a once busy city where the last shop closes, and the neon signs flicker out. After that, stars will start aging out. Our own sun has a few billion years left in it, but eventually it'll swell, shrink, and fade. Across the universe, the same story will play out. Bright, young stars will dwindle into faint embers, white dwarfs cooling into black dwarfs. Neutron stars will sit in the dark like forgotten relics. Black holes will keep doing their mysterious thing, swallowing whatever drifts too close. The night sky, once blazing blazing with constellations, will become sparse, then barren. Imagine looking up and seeing nothing, a blank, dark canvas. But here's where it gets both eerie and fascinating. Even in that darkness, the universe doesn't just stop. Physics keeps grinding on, like a metronome ticking in the background. Planets will keep orbiting dead stars for a while, but eventually, even those will drift away. Gravity, collisions, and sheer cosmic boredom will scatter them into the void. Picture an old party where the music stopped hours ago, but a few stubborn guests are still shuffling around awkwardly. That's the universe after stars are gone, an after-party that just won't end. Now, if you zoom even further into the future, things get wild. Enter what physicists call heat death. It sounds dramatic, but it's basically the ultimate anticlimax. Heat death means everything spreads out so evenly, so randomly, that there's no energy left to do anything interesting. No clumps, no stars, no light. Just a uniform haze of particles, buzzing with the tiniest scraps of motion. Imagine the world's longest Netflix binge, but the screen is frozen on 1 pixel of static. That's heat death, the universe as a grey, unchanging fog. Of course, not everyone buys into that gloomy ending. Some physicists say, hold on, maybe the story doesn't just fade out. Maybe the universe has a trick up its sleeve. For example, what if it cycles? Expand, collapse, expand again. A cosmic breathing rhythm, where heat death is just an exhale before the next big inhale. That would mean the universe could renew itself endlessly. New stars, new galaxies, new possibilities. If that's true, the universe isn't dying. It's reincarnating. Cue dramatic theme music. Then there's another idea. Cosmic inflation might still be bubbling away in the background, creating new baby universes, while ours grows old. Think of it like popcorn popping. Our universe is one fluffy kernel, but elsewhere in the cosmic microwave, new kernels might be exploding into being. In that picture, the end of our universe isn't really an end at all. It's just one bubble in an infinite cosmic jacuzzi. Not bad, right? Still, the theories keep tugging between silence and renewal. Heat death says, everything winds down, full stop. Cyclic models whisper, don't worry, there's a next round. The multiverse idea suggests, your universe might end, but don't sweat it. There are others. And somewhere in the middle, black holes slowly evaporate, particle by particle, until they vanish. Even the most stubborn objects in existence can't resist the slow erosion of time. It's like cosmic patience. Given long enough, everything dissolves. If all this sounds bleak, here's a flip. The fact that we can even imagine these possibilities is astonishing. You're lying here on a rock orbiting a middle-aged star, and your brain can run simulations about what happens not just after you're gone, but after your species is gone, after your planet is gone, after stars themselves are gone. You're basically time traveling with thought alone. Not bad for a bunch of neurons firing in a 3-pound lump of grey matter. And think about this. The future may belong to silence, but silence isn't nothing. Even in the darkest scenarios, particles will still drift, black holes will still whisper radiation, the laws of physics will still hum beneath it all. Endings in the universe aren't hard stops. They're fade-outs, transformations, shifts into new states. So while the party might end, the house itself is still standing, waiting for whatever comes next. Of course, this raises the ultimate question. Does the universe actually have a purpose, or are we the ones assigning purpose because we can't resist a good story? Maybe the cosmos doesn't care if it ends in fireworks or static. Maybe meaning is something we invent, like writing poetry about a campfire even after the flames go out. And maybe that's the renewal, not of stars or galaxies, but of awareness itself. As long as there are minds to ask, what comes after, the story keeps going. So here's where we land. The far future could be silence, or it could be renewal. Both possibilities carry their own kind of awe. Silence shows the sheer power of entropy, the idea that everything eventually evens out. Renewal hints at cycles, rebirths universes without end. Either way, you're part of the chapter that gets to wonder about it, which is something neither stars nor black holes can do. That's your cosmic cameo, the question asker in a play that stretches across eternity. And as you drift tonight, think of this. Maybe you're not meant to solve the ending. Maybe you're meant to hold the question, to let it sway at the edge of your thoughts, like a lull in a song. Is it silence? Is it renewal? Either way, the horizon is vast. The possibilities are unspooled. And you, curious, stardust-made, dream-prone you, are listening as the curtain flutters but never quite falls. Now keep that question tucked in your mind, because the story isn't over. There's one more chapter, and in it, we'll stop chasing stars and time and come back to the simplest mystery of all, your place in the infinite. Here's a paradox to sleep on. You are astonishingly small and impossibly vast at the very same time. A human being under one fragile blanket, on one spinning rock, in one galaxy among billions. By any cosmic yardstick, you're microscopic. Yet somehow, you also contain thoughts about eternity, dreams that stretch beyond galaxies, and questions that poke at the edge of reality itself. How strange is that? You, the small creature who misplaces socks and forgets phone chargers, are also the narrator of infinity. Think of it this way. If the universe were a library, you might assume you're just one dog-eared page in a dusty book shoved on a bottom shelf. But in reality, you're also the reader, the one turning pages, asking what happens next, and daring to imagine stories that the shelves themselves cannot contain. Your smallness is the ink, but your vastness is the act of reading the whole library aloud. That duality, that dance between tiny and enormous, is your place in the infinite. Let's scale out for a second. Earth itself is a dot, smaller than a grain of sand if the Milky Way were a beach. And our galaxy? Just one swirl in a cosmic ocean. The universe doesn't even bother to keep count after a while. Galaxies pile up like glitter spilled across black velvet. Yet here's the kicker. Inside your skull, neurons fire in patterns that mirror those galactic webs. The structures of thought and the structures of space aren't identical, but they rhyme in a way that feels like the universe is winking. You're not outside the story. You're written into the same poetry. But wait, doesn't the idea of infinity make your head spin? You're not alone. Philosophers have wrestled with infinity for millennia, and physicists still get headaches trying to tame it. Infinity is slippery. It's not just a really big number. It's the concept that there is no edge, no ceiling, no end. And when you try to picture it, your brain throws up its hands and says, "Look, I wasn't designed for this. I evolved to find berries, not to map eternity." Yet here you are, berries long forgotten, staring into forever and trying to draw a map anyway. That's the wonder of it. You don't have to grasp infinity in a neat equation. It's enough to feel its hum, the way you feel the ocean without needing to count every drop of water. Infinity isn't there for you to solve. It's there for you to stand inside, knowing that your very act of asking gives it meaning. After all, what's the point of an endless cosmos if there's no one around to say, "Wow"? And speaking of wow, your body is a mosaic of stardust. The calcium in your bones, the iron in your blood, the carbon in your cells, all forged in the cores of stars that exploded long before the sun was even born. That makes you not just in the universe, but of the universe. The atoms that make you are older than Earth, older than your solar system, maybe even older than your imagination dares to stretch. You are history embodied, carrying fragments of cosmic explosions in every heartbeat. But flip the telescope. You're also home to worlds within worlds. Trillions of microbes call you their planet. The electrical chatter of your brain forms galaxies of thought. When you dream, you generate whole universes of experience, tiny pocket realities flickering in the night. In one direction, you dissolve into the infinite vastness of stars. In the other, you bloom into infinite inner landscapes. Smallness and vastness, again, always both. Now, if all this makes you feel dizzy, don't worry. Feeling small doesn't mean feeling insignificant. In fact, the very fact that you can recognize your smallness means you've already stepped into your vastness. A raindrop doesn't know it's part of an ocean. But you know. You know you're part of galaxies, and galaxies are part of you. That awareness alone is a kind of cosmic superpower. Here's a fun twist. Some physicists believe the universe may not even contain you in the way you imagine. Instead, you're inseparable from it, like a wave rising on the surface of an ocean. The wave doesn't exist without the water, and you don't exist without the cosmos. Your thoughts, your heartbeat, your life, they're not separate events happening inside a universe. They are the universe experiencing itself from one particular angle. Imagine the cosmos throwing on VR goggles and saying, "Okay, tonight I'm going to be you." That's your place in the infinite. Not a guest, not a bystander, but a participant. The laws of physics aren't out there. They're pulsing through your veins. The mysteries of consciousness aren't detached. They're happening as you listen. You're not watching the story unfold. You are one of its central sentences, spoken in real time. And yes, someday, your personal page in this grand story will close. But the atoms that form you will scatter, rejoin the cosmic dance, and build new forms. The carbon from your cells might fuel a plant. The iron in your blood might one day rest in a planet's core. Matter doesn't vanish, it transforms. You're not just a fleeting presence. You're a chapter that gets recycled into other chapters endlessly, which brings us back to infinity. The universe may expand forever, or loop back in cycles, or splinter into multiverses. Scientists debate and theories multiply. But your place is here, in this moment of wonder, in this fleeting awareness. The grand unknown doesn't diminish you, it frames you. You're the consciousness, flickering against eternity, the question mark in the margin of an endless book. So what are you in the infinite? You're a contradiction and a harmony, a small body but a vast awareness, a single note but also the song. You're the silence between stars and the laughter of neurons firing in the dark. You're a bridge between what is known and what is not, between the brief spark of human life and the timeless sprawl of the cosmos. And maybe that's enough. Maybe your place in the infinite isn't about conquering it or solving it, but belonging to it, belonging to the wonder, the mystery, the never-ending questions. The stars don't ask why they shine. Black holes don't ponder their destiny. But you do. And that's the magic. That's the universe waking up inside itself, curious and restless, always looking for meaning. As you drift into sleep tonight, remember this. You don't just live in the cosmos. The cosmos lives in you. Every breath is proof. Every thought is evidence. You are both question and answer, both silence and song. And in the grand sweep of infinite time, that might be the most remarkable fact of all. The stars are still out there, keeping watch. The story is still unfolding, and you, tiny, vast, fleeting, eternal you are woven into its fabric. The curtain doesn't fall because there is no final stage, only endless horizons, only boundless possibilities. And here, at the end of our journey together, you belong, utterly and completely, to the infinite.